Hello everyone. So let's start with arrays in C. So we are going to learn about arrays in C. This is about data structures in C programming language. So C programming language is the classic programming language, one of the first general purpose programming languages. So we can include it like this, or prefer this way. It works most of the time, that's why. And we have our main function. You can have the command line arguments stuff, which is argc and argv. You can have brackets like this. I prefer whatever based on the programming language. So in C I prefer this way. So let's get refreshed by printing hello world, and just getting the backend running. So yeah, let's create an integer array, right? In C you can create static arrays, right? This is called a static array, in which so let's define what's a static array. So static array is an array in which the size of the array is fixed, right? And from the static you might infer that there is also dynamic arrays. So dynamic array is an array in which the size of the array is variable, means it can be changed, right? Can be changed. So let's define what is the size of an array, right? Size of an array is, simply put, the number of elements in the array, right? And what is an array? An array is a data structure to hold or to store similar or data of the same type. Rather, I would rather put it as sequential data of the same type. So usually it's sequential, right? And this is basically one dimensional array. So what is a dimension of an array? So what is the dimension of an array? It's a feature in programming languages to allow us to store complex data, right? You can store very complicated data, like we talk about arrays as a list of things, right? So you can have your grocery list, right? Let me put it in code itself so that you'll understand it in a better way. So it'll be a string um, in C. You don't have strings. You can do it this way. Now I have a string, right? um, Let me do it this way. This is correct, right? And I'll create an array of strings, right? This will be called grocery list. And let's say I have 3 items in my grocery list. So the first item, right, is what? It is, let's say, eggs. And second item, grocery list of 1, is milk. And grocery list of 2, let's say it is onion. Okay, so now you might be thinking, how do I print these elements, right? How do I print my grocery list? I want it in different lines. So grocery list length I plus plus, and we'll print it like so. Um, percentage s backslash n, and we'll have grocery list of I. So this piece of code has some problems. So first of all, this variable in grocery list length, um, it's better for me to define it here just before the array. And also this length is same as the size, right? Size, some languages call it length, some languages call it count, right? So it's all the same. So if I try to run this, you'll see that there are some issues. First of all, you shouldn't have semicolon over here, because yeah, I was initially going to do a type def. So type def, so it should be not, it should be the other way, right? So this is how you create an array. Array is just a list of things. So this is one dimensional array, right? So it has a list of things. So if you think of two-dimensional arrays, you can think of a matrix, right? So let's put one dimension array over here. Think of two-dimensional arrays. It is a matrix, two-dimensional array. So you can think of it as a matrix, as a table, as rows and columns. So let me define an array over here, so, or a matrix or a two-dimensional array. So it'll have two indices, right? Or I'll make it 2 by 2 just for simplification, just to make everything simple. Let's have 1 comma 2 and 3 comma 4. You can see that it's rows and columns, right? And if I want to access them, you can have I prefer int m is equal to 2, int n is equal to 2, and I prefer to store my arrays in this fashion. I less than m, I plus plus, right? For int j is equal to 0, j less than n, j plus plus. And let's print out like so, right? I'll use space as um, the separator for one row, for the elements in a row. So we'll use matrix of I comma j, I j, and we'll print a backslash n over here, which is new line character. So let's try running this and see if we have any problem. It is saying that variable sized object might not be initialized. Oh, okay. So the issue is, as I've said before, we create static arrays this way. These needs to be constants. This only works in C++, I guess. So hopefully this works. I'm not sure. So this works. So why did this work, right? And this not work? Because this last element, it can be variable. I'll show you what I mean. N is equal to 2, right? array type has an incomplete element. Variable sized object, or is it the other way? Let me verify that. Let me verify that. Okay. Um, Variable sized object may not be initialized. So C has these, or static arrays in C have these weird restrictions which we all might not know, right? Um, Let me make this more presentable. So you can have these delimiters, right? And this will look more like a matrix. So now that we know what a dimension is, so what is a dimension? It is it is the number of, essentially the number of indices, but I want to give it a better definition, right? The number of, not hierarchy, but the number of complexity. Complexity is a good word because it's easy to then associate the time complexity. But let's say it is the um, number of features, number of, let's call it features or indices in an array. So usually people don't define um, these keywords so specifically. I am trying to challenge myself by doing that. So let's see. So we know what is a one-dimensional array, what is a two-dimensional static array. So these are static arrays, and sometimes you'll have to make these constants. Let's make a dynamic array. So we are going to make a dynamic array, and we are going to make a class or a structure um, which complements the dynamic array, or which can enumerate, encapsulate the dynamic array. So let's create a dynamic array. Dynamic array is an array whose size can be determined at runtime, or is det I'm giving them better definitions at compile time, right? Determined at runtime, right? This is a better definition. So we know how to take input from the user, even though this is very bad. This is a major security flaw, but let's take input from the user, right? Now we have this n. We don't know what the value of n is at compile time, but we want to create an array, right? Array of integers. um, so in C, this is how you create an array of integers, n times size of int, right? So this is how you create an array of integers. So let's say, mm, so let's input the array I plus plus scanf g ampersand arr of I, mm, and let's print the array. And percentage d arr of I. I think this should be good enough. Let's see where is the issue. Right. Let's just comment all these stuff so that it doesn't get cluttered and it doesn't spoil what we are going to do. So we need stdlib.h for the function malloc, um, and I'll explain what each of those things do, right? I'll explain what each of the line means, right? Right. So we are taking, so let me just create a logger function, right? Log, I'll call it info for now. um, String message and printf percentage s message, right? So this is my logger function. So what am I doing in the next line is I'm initializing n to 1. So I'm being very verbose and explaining what each of the line is doing. And I'm taking input an integer input, or I'm expecting integer input from the user and storing it in n, right? I'm expecting that. And here what am I doing? I am creating a dynamic array, right? I'm creating a dynamic array by using malloc function. So what does this malloc do? Malloc of n, right, creates n bytes of memory, right? Or allocates n bytes of memory. And how you structure this memory is based on this. We are casting these bytes. So initially there'll be bytes. So what are bytes? They are un um, unsigned char. So the unsigned chars are bytes, right? And let me also free ARR just to be memory safe. So bytes, right? And we are also casting the bytes to integer pointer of type integer. Essentially that's what we are doing. And we are taking, I log this, taking or rather, let's use the same terminology, which is expecting, because the user can type anything, right? Expecting integer array input from the user and storing it in ARR. And I am also printing the ARR, the integer array ARR to screen. So this is what I'm doing. And finally, I'm deallocating or freeing the memory allocated by malloc. So this is what I'm doing. So let's run this, and let me just um, improve my log function, right? This should be good enough. And right, see, this is what happens when you give the wrong input. So let's say I want to enter three numbers, right? 1, 2, 3. It has printed 1, 2, and 3. Let's create a function. I would rather make it a macro as printf backslash n. Let's add a new line after this, right? 3, 1, 2, 3, and this looks very good. So you might see some things cut off from the screen, right? Don't worry, that is okay. You know what we are typing. Um, let's see. We are done with dynamic arrays, right? Now let's create, right? Let's create something. I'm bored of doing all this. Let's create something. Let's create a struct, right? I'll create my main function here. I'm creating it over here, and let's create a struct here. I'll call it array, right? um, Let me use bad C programming practice, which is um, I mean, it's not bad, it's just convention, it's not the recommended convention, right? um, let's call it integer array. So usually structs, we name it in lowercase, but it's fine. This is also pretty standard practice. So what data do we hold? So in structures we have data, right? Structures in C can only hold data. It can't. It can hold pointer to functions, but um, that is, I feel, out of scope. If you're interested, I will be happy to go about it. So let's see. What data are we holding? We are obviously holding a pointer. Let's call it v, right? So this is the pointer to the array, right? We'll call it v, and I'll also have the number or the number of elements in the array, right? So we have these two things, these two data that we are holding, and we can also have functions, but in C it's a bit weird, right, compared to other object oriented programming languages. So we'll have obviously a constructor, right, which will, let's have two constructors. um, Init size, init width size, let's say, where we have int n, and obviously we'll also have to pass, um, let's do this, um, or let's do it this way. Okay, right, let's integer array arr, right, arr. You see, you can do this, you can do this, um, you can also do this. All those optimizations are fine, and you can do this. So um, for argument's sake, um, so let's do this. Arr of v is equal to int star malloc, malloc of n times size of int. So we have seen this, right? So we have this, and let's have another function. Let's call it print array, right? Const integer array arr, and let's print it, right? Arr of n I plus plus. This is pretty standard what we are doing, and arr of v of I. We can do some assertions, we can do some checks before this. To check, we can initialize this to 0, and we can check if arr of n is, so first of all we can check if this is null, right, or null ptr. I think that is only C++, so we can check this. We can print something, printf um, array has not been initialized, and let's create an error logger. Let's create an error logger. I'll uncomment this logger. I'll uncomment this. Let that be there, because a logger needs that. Error string message printf error. I think we are 100 lines of code already. That's good. Message. So I think that should be fine. So let's call this error method. Let me just, okay, it's fine. And let's check another error. ARR of n, if it's less than or equal to 0, then error array does not have any elements, right? Let's have these two errors, these pre-checks, and let's also print n, so we can have, let's say we have um, add or set function, right? uh, const integer array arr int index int value, right? And let's define this function. um, let's have these prechecks. I'll call these boolean or just void prechecks. uh, let's call it boolean, right? We'll call it bool. I think C99 allows that, or else we can use int pre-check pre-check array, right? And let's pass the array arr, and this, what will this return? This will return false, this will return false, this will return true. um, I'll call it is valid array, right? Then this will be false, this will be false, this will be true, and we do this only if is valid array. Or we can guard it, we can add a guard statement like this: if not is valid array arr return, right? And let's do the setting part. We can also check for overflow. We need to check for array index out of bounds, right? Bool is array index out of bounds, right? And what do we pass? We pass integer array arr and int n, and we check if n is less than 0, or we check I. We check if I is less than 0, then it is out of bounds, or if I is greater or equal to arr of n, right? That makes sense. So we check if, so let's do it this way. If this is the case, we are returning true first of all, and we log the error message as array is out of bounds. Array is out of bounds. So we check is array out of bounds of arr, then we return. Only then we do arr v of I is equal to n, which is index value, and don't forget here it is index, void get const integer arr array arr int index, and we again check if it's valid array. We are guarding against this, so we are putting a not, and we return, if that's the case, is array out of bounds. We are checking ARR index, then we are returning let's return -1 for now, and let's make this int. Then we are returning, wait, we are returning this value. I could do better things, but better way of doing it, but this is probably the easiest way to understand it. ARR of v of index, right? And let's initialize the array to 0. Let's initialize the array to 0. ARR of v of I is equal to 0, right? Initially it will be 0. Now that we have some functions, let's create our main program. So first of all, we are going to create an array, which is an integer array, right? Let's declare it at least. Then we'll init with size 5, let's say. We are just testing it right now. Let's print the array, right? And let's run this and see if there are any errors which we have missed. And let's deallocate or void free the, what do we want to call it? Let's call it free array const integer array star arr, and we are freeing arr, and let's free the array at the end. Let me just refresh. Okay, we have to get rid of all the const. To get rid of all the const. Hmm. Let's see this. Yeah, we'll have to get rid of all the const. This is not JavaScript, so it doesn't work like this. Uh, this can be const. Let's see what can be const. This can't be const. This can be const. This can be const. Okay. Can this be const? Yeah, we are just doing checks. So if you're not changing anything, it can be const. Is validatory. Bool. Bool is okay. Let's just define bool as unsigned int. right? Unsigned char has defined true as 1, has defined false as 0, I guess. I don't know if true and false are defined before. Is array index, right? Index out of bounds. And we are getting segmentation fault. So segmentation fault is um, you're going through memory which you don't have access to. So yeah, so we forgot ARR is equal to integer array star malloc of size of integer array. So we forgot to do this. I think that is fine. Let's print the array. It should be by zeros. Array has not been initialized. Right. So we'll have to return this value, right? We'll have to return it. So let's say this is integer array, right? And we are not passing this actually. We are creating this integer array and we are returning this. So I hope this works. So this is what we wanted. And let me log some stuff. Let me log some stuff. What is it? What are we doing here? Allocating integer array using malloc. That's what we are doing here. What are we doing here? Initializing the size of the integer array. So which is n, right? Sizes n. So allocating the memory for container, we'll call it the container, right, of integer array. Actually we can rename this n to size and v to container if we want to be, and I to index, I guess, yeah, to be more verbose and better programming. So we can do that. So what are we doing here? We are initializing integer array elements to 0, right? All the elements we are initializing to 0, and we are checking if the array has been initialized, right? Here we are checking, right? We are checking if array has any elements. If array has any elements, again we are checking if array index is out of bounds. All these are checks, we are checking them. We are checking, and I think this is not required because this does that, and printing the array to the console. It's good to write logs like this. Setting the value, setting the integer array at in index I with value as index and value, right? And we are getting the in value of integer array at index I, and we are also allocating memory as allocated of integer array. Allocated, who allocated this? By malloc. So who allocated this seems to be a weird question, but in C++ it makes more sense because different people can allocate and deallocate memory. I've forgotten some, um, let's see, size, forgotten that. Okay, okay, let's see. Let's let me show you something. Let us print or printf definition in C. So let's see, printf definition, right? Probably this should work. Okay. Hmm. Let's see the printf implementation in C. I want to see that. So this is how you learn, right? If you know how printf works, so it'll be in the libc function. Hmm. Okay, they're doing it that way. But how do you pass? You know what? This is too complicated. Let's do it the. Hmm, is it sprintf? What does this do? Let's see string format in C, right? C lang sometimes this works because hmm, okay, let's do it another way. I want to define where args in C. Let's see how do you do that. Okay, let's do it another way. Hmm, the issue with C is it doesn't concatenate strings. That's the big issue with string is. What does sprintf do? Okay, I want this to return that. It's a char buffer. Okay. Okay. Let's do it this way. Okay. Or let's not do this at all. Setting at index with value, right? It takes some time and research to figure that out. So what I wanted to do is use a variable use variable arguments to write initialize, allocate, check if I have been initialized. Right, this looks good. So I wanted to create a variable args um, structure to log, right? similar to what printf does. uh, I could have probably used macros to achieve that. mm, Probably, yeah. And let's remove this. So this is what is happening. So let's try setting something, right? Set at index 3, which is the fourth element, with value 5, print array, right? See, the fourth element is 5. So let's say you want to print something. So print the third element or fourth element. Get ARR of 3, which is the fourth element, and this should be 5. Let's format stuff properly. This is 5. That makes sense. Now let's test index out of bounds, right? So 5 is obviously index out of bounds, and we'll also, since we are not exiting, we can also try another type of index out of bounds, which is negative. So there should be 2 array indexes out of bounds. Errors. Let me fix the format. This should be error, and the function array index is out of bounds, right? So we got to test that. Now let's see, what have we not done. Yeah, we have done, everything. So let's say you want to set 1 and s2, and let's print this array. Let's print this array. This makes sense. At index 1 it is 2. We can we cannot do we can reinitialize or double the size of the array, but we'll have to free, right? We have to free this like so, and we can double the size of the array, right? And we can print this array, and we can also free, because that is important. We should free the memory. Let's see. So you can see that there are 10 elements and we are freeing it. So you can change it like this, but you'll have to free 4. So by using this approach, you can create something called a vector in C++. You can create an array list in Java. You can create vec of integer in Rust. So you can create these actually dynamic arrays, right? In which you can change the size. You'll have a variation of add or insert or push function, push back, push front functions. You'll have remove function or pop function. You'll have all these functions, right? Which you can use this concept of doubling the size of the array whenever it goes, whenever the size overflows, right? So you can double the size of the array, and you'll have an amortized cost of O of 1. So the overall you'll have insertion and deletion cost of 1, O of 1, which is at the end, right? So let's see. I feel like that's all I had to contribute. So I hope you liked it. We are past the 1 hour mark. And that was my goal. Thank you for watching. Have a nice day.